All right, welcome back. This is part 2 of the review. So we're going to start on page 3 of the review sheet and go through the rest of it. So here we go. We'll start at the top with 27. And 27 says to simplify and express your answer in terms of I. Okay, so we've got things like the square root of negative 25. And whenever you have that negative under the square root, that's obviously comes out as an I. You can think of this as the square root of negative 1 multiplied by 25. But this negative under the square root comes out as I. And once you've pulled that out, then you can take the square root of 25. That's obviously 5. And we end up with 5i. Let's look at 28. 28 talks about multiplying and dividing complex numbers. So let's just pick, let's say B, and say that's 4 plus 3i. And that gets multiplied by negative 3 plus 7i. Now this gets FOILed, so 4 times negative 3, that gives me negative 12. And then 4 times 7i, well, 4 times 7 is 28, and then times I gives you 28i. 3i times negative 3 is negative 9i. And then 3i times 7i, 3 times 7 is 21. And you have I times I, which is I squared. And it's this I squared that we want to see simplified, right? If you have I squared or I third or I to the fourth, it needs to be turned down to in terms of I. But I squared is negative 1. So I can rewrite this as negative 12. I can combine my I terms here. 28 and minus 9 gives me plus 19i. And then this I squared becomes negative 1. And so that's plus 21 times negative 1. Then, of course, 21 times negative 1 is minus 21. And I can combine the real value portion of these. Negative 12 minus 21 becomes negative 33. And then you still have plus 19i. Let's look at the division. Let's look at, let's say, D. D is 3 minus I over 2 plus I. And so to do this, you're going to multiply both the top and the bottom by the conjugate of the denominator. So the conjugate of 2 plus I is 2 minus I. You just switch that sign in the middle. But I multiply both the top and the bottom, and then I just FOIL just like we did up there. 3 times 2 is 6. 3 times minus I is minus 3i. Minus I times 2 is negative 2i. And then negative I times negative I, it's a negative times a negative, so it's plus, but it's still I squared. And then again in a second, that I squared is going to become negative 1. That's my numerator. My denominator, I'll go through and FOIL as well. 2 times 2 is 4. 2 times negative I is minus 2i. I times 2 is plus 2i. And then I have I times negative I, which is minus I squared. So if I clean it up a little bit, I can add my I terms in the numerator. Minus 3i, minus 2i, I can combine those together. I can also combine the I terms in the denominator. So 6 minus 3i and minus 2i becomes minus 5i. And then plus I squared, but I squared is negative 1, so this becomes minus 1. All over 4 minus 2i and positive 2i cancel out. Then I have minus I squared. But again, I squared becomes negative 1. So in the numerator, I can combine 6 and negative 1 becomes 5. And I still have minus 5i. And in the denominator, I have 4 minus negative 1. That's 4 plus 1, so that's 5. And because everything is divisible by 5, right? In order to be able to simplify with the denominator, you need to be able to factor out something that simplifies. And since I can factor out of 5, those will simplify, and my final answer is just 1 minus I. So let's look at 29. And let's do, let's say B. So I to the 57, right? If you remember when we had just a minute ago, we just said I squared is negative 1. But I to the third is I times I squared. But if I squared is negative 1, this is just I times negative 1, which is negative I. So I can simplify I to the third down to an I. But if I get to I to the fourth, that's I squared times I squared. But I squared is negative 1. And so negative 1 times negative 1 is 1 again. Okay? And it's this fact right here that I to the fourth is going to be turning into 1, that if I have I to the 57th, I can say that that's I to the fourth times I to the fourth times I to the fourth times I to the fourth, however many 4s I can get pulled out of this. In fact, I can turn that into, 14? I can pull 14 4s out of there. And then what am I left with? So rather than doing it bit by bit like that, what I can say is I know that 56 is divisible by 4. And so if I can turn some power of 4 over here, I'm going to rewrite this as I to the 56 times I. That leaves me just the 1 left over. Because 56 is 4 times 14. And so this is like 14 I to the fourth, but they're all 1. So it's 1 times 1 times 1 times 1, 14 times in a row until you get to this last guy here that's just there. And so all of these guys turn into 1. This guy's still I. And so I to the 57th is the same as I. Let's take a look at 30. So it says solve and then find all solutions, either real or complex. So let's grab one. I think E might have complex, but we'll find out in a second. X squared equals negative 15 minus 8x. So it's a quadratic. It has a second degree, which means I'm going to bring everything to one side and set it equal to 0. So I'll add 15 and I'll add 8x to both sides. So that gives me on the left x squared, and I'll write it as plus 8x and then plus 15. And on the right-hand side, those cancel out, so I just have 0. Now, this is not going to end up having any imaginary solutions because I can factor this. This turns out to be x plus 3 times x plus 5 equals 0. And that one's easy. I just set each of these equal to 0. Either x plus 3 is equal to 0, or x plus 5 is equal to 0. And then you solve each of these by subtracting 3 on the first one, and that gives you x equals negative 3. Or subtract 5, and that gives you x equals -5. So let's look at f. F is 2x squared minus 5. It says 5t on the review sheet, but it should be minus 5x equals 1. So again, since it's a second degree polynomial, I'm going to get everything onto the left-hand side. So I'm going to subtract 1 from both sides. This leaves me with 2x squared minus 5x minus 1 equals 0. And I can't factor this one, right? So I'm going to have to use the quadratic. And the quadratic is negative b plus or minus the square root of b squared minus 4ac all over 2a. And so a is 2, b is -5, and c is -1, and I'll plug it in there. So this becomes x equals negative b, but b is -5, so negative b is +5, plus or minus the square root of b squared, so that's -5 squared, minus 4 times a, which is 2, times c, which is -1. That's all under your square root, and then we're over 2 times a, so 2 times 2. And we'll simplify. So this is 5 plus or minus the square root. -5 squared is 25. -4 times 2 is -8, but then times that -1 gives me +8. And so we can see that we're going to end up getting real values because this number under here is positive. Still over 4. But with those real values under that square root, I've got 25 plus 8. Oops, 33. I don't know what the square root of 33 is. I can't simplify that. And so this is my solution. I have 2 solutions. One is where it's plus, and the other is where it's negative. But if you write it just like this on the final, that's good as well. And then the only difference you might see on here, the one I was looking for was one that would come up with an imaginary solution. But that just means under your square root, you'd have a negative. And if that's the case, you pull that out as an I, and that's it. You're done. Okay. Let's look at 32. 32 says solve. And A is a pretty good one. It's got 1 over 4 plus 1 over 5 equals 1 over t. So what we do here is try to eliminate all of that denominator. The greatest common denominator here is just the product of 4, 5, and t. So I'm going to multiply everything by the product of 4, 5, and t, which is 20t. So I'm using the multiplication principle, so I multiply both the left and the right-hand sides, and on the left-hand side, it distributes to both of the terms. I don't know why it's being weird right now, but let me try to get that in there. 20t multiplied there, and then here I get multiplied by 20t as well. Okay. With the t on the very left cancels with the t, so on the right-hand side, or sorry, the t on the very right cancels with the t in the denominator, so on the very right-hand side I just have 20. But here the 20 simplifies with the 5, leaving you with the 4, so I have 4t. On the left, the 20 simplifies with the 4, leaving you with the 5. You still have that t, so that's 5t. And then I just add these together, 5 and 4t, 9t, and divide each side by 9. And t is 20/9. Let's look at 33. We've got some radical equations here. 33 says solve the following equations, and you're given something like, say, let's do b. B is 2 minus x under a square root minus 4 equals 6. So the first thing I want to do is isolate this entire absolute value. And I do that by adding 4 to both sides. So I've got the square root of 2 minus x is equal to 10. And then I'll square both sides, because if I square the left-hand side, that square cancels out the square root, and I just square the right-hand side as well. And so I end up with 2 minus x is equal to 100. And I continue to solve. So minus 2 from both sides. Leaves me with negative x equals 98. I want this negative out of here, so I'm going to multiply the left-hand side by negative 1, multiply the right-hand side by negative 1, and that gives me x equals negative 98. And I'm done. Know how to manipulate an absolute value equation. So on 34, we're given, let's say, 3x plus 1 in an absolute value. This is c. Plus 7 equals 12. So like the square root, I want to isolate that absolute value expression. So I'm going to subtract 7 from both sides. This gives me the absolute value completely isolated on the left is equal to 5. And now that I have that absolute value equals some number, then whatever's inside the absolute value, this 3x minus 1, its absolute value is 5, which means one of two things. That it is 5 itself, or it could be negative 5. Because in either case, the absolute value of 3x plus 1 then is 5. And so I solve both of these equations. So that's the biggest thing I see missed on finals, is when you have the absolute value of some expression equals something, you need to turn it into those two equations and solve both. So if I subtract 1 on the left equation, that gives me 3x equals 4. Divide each side by 3, and I have x equals 4/3. That's one of my solutions. And on the right one, if I subtract 1, I get 3x equals negative 6. And, excuse me, sorry, divide both sides by 3, and that leads me to x equals negative 2. And those are my two solutions. Okay. Let's take a look at 37. It says solve the following inequalities. And let's use, let's go for A. A says, well, I have x minus 2 over x plus 4 is less than 0. And we're going to concern ourselves with the behavior of the left-hand side. I've got this less than 0. I've got a 0 on the right-hand side. That's great. That's what I want. So on a number line, we're going to kind of play with this and see what happens to this graph. But in the numerator, if x minus 2 is equal to 0, then the function itself on the left-hand side is equal to 0. And so that's easy to solve for. I just add 2 to both sides, and x equals 2. So at 2, I'm going to fill this in with the dot that indicates that it is a 0 there, right? But in the denominator, if x plus 4 is equal to 0, then I have an asymptote. That expression is at an asymptote. So if I solve that, I've got minus 4. That gives me x equals negative 4. And so at negative 4, I'm going to write negative 4 here in an open circle here, right? Because I know I have an asymptote there. And that's all the zeros. So the zeros of the numerator is a real 0. And the zeros of the denominator give you the asymptote. But that cuts my number line into 3 different areas. Right? To the left of negative 4 is one of the areas. Between negative 4 and 2 is the second area. And then from 2 onward is the third. And all I really need to do is find one of those values. So if I find, and let's say I'm going to plug in 0 just because it's really easy. 0's something nice and easy to plug in to the x's of the function. And all I really care about is if when I plug in 0, do I get a positive or negative out of this? So if I do, if I plug in 0, I get 0 minus 2, which is just minus 2, over 0 plus 4, which is just 4. And I don't really care how negative it is. A negative divided by a positive is negative. That's it. I've just got a negative here. And so in this region, it's negative, right? But this 0 of the numerator has multiplicity of 1. And so when I jump over that, I change signs. I go from negative to positive. That's where we cross on those graphs. But the same concept applies when I jump over an asymptote, except instead of going through the x-axis, I'm going to shoot down all the way down to negative infinity on one side, but then come back from positive infinity, and I'm going to change signs as I jump over an asymptote with multiplicity 1 as well. And so I have positive here. And so the only places that this inequality is satisfied, when this is less than 0, that's when this thing is negative. And so in interval notation, it's between negative 4 and 2. It's not including negative 4 because negative 4 is an asymptote and there is no value at negative 4, but it's also not including 2 because it's a strict inequality, and it is 0 at 2. It's not less than 0. And so our final solution is that interval, negative 4 to 2. Let's look at 38. 38 says find the inverse. Of the function. We might have some function f of x equals, let's do c, 5x minus 3 over 2x plus 1. Now the key here is to, when we're trying to find the inverse, the first thing I want to do is ditch function notation and rewrite f of x as y. And then I'm going to swap my x's and my y's. So this y becomes an x, and then my x's on the right-hand side become y's. And then I want to solve this thing for y. So the first thing I want to do is to get this 2y plus 1 out of the denominator, and I do that by multiplying by 2y plus 1, which of course, if I multiply the right-hand side by it, I have to multiply the left-hand side by it as well. But it cancels on the right-hand side, and I get 2y plus 1. I'm going to distribute this x through because I don't want the parentheses over here. So I'm going to write this as 2xy plus x on the left-hand side is equal to 5y minus 3 on the right. And the reason I distribute it is because I want my y terms, which I have two. I have a 2xy and I have a 5y. But I want anything with a y on one side and anything without a y on the other side. So I'm going to subtract x from both sides. But I'm also going to subtract 5y from both sides. The x's cancel on the left, the 5y's cancel on the right. And I've got all of my terms that involve a y on the left. And anything that doesn't have a y on the right. That's not helpful. There we go. And so in both of these terms, I've got a y. That means I can factor that y out. And so I'll pull it out, y, put it on the left. Now leaves me with 2x minus 5 equals -3 minus x. And now we just have this one y. I need to solve for it, and that's easily done by just dividing by the other factor of 2x minus 5. Cancels on the left. I've isolated my y, so y equals -3 minus x over 2x minus 5. Right. And if you did this on your own and you got a different looking expression, there's a couple of ways you could have this written, depending on if you factor a negative out of the numerator, and you can take a negative out of the numerator and put it in the denominator. But there are a few ways that this particular one could look. But this is a solution. You also might see 3 plus x over 5 minus 2x. That's the same thing. You know, there's a couple of ways that you could write the same expression. All right, so let's look at 42. Expresses a single log, and then simplify if possible. So you've got in A, you've got 3 logs. In B, you've got 3 logs. The idea is the same. On the left one here, I've got coefficients. So the first thing I want to do is take this 1/2 and rewrite it as a power over my x, and do the same thing with my 4 and the same thing with my 3. So I would rewrite this as the log base a of x to the 1/2, which is the same thing as log base a of the square root of x, plus the log base a of y to the 4th power, and then minus the log base a of x to the 3rd. And then these guys, log base a of x to the 1/2 plus log base a of y to the 4th, those are both positive logs, so they're going to become products in the numerator. And then this negative right here is going to make this x to the 3rd in the denominator. So we would see a single log being formed of the product of x to the 1/4, or sorry, 1/2, and y to the 4th. And then this, because this is negative here, that x to the 3rd goes into the denominator. And then simplify if possible. You can simplify because your x has a 1/2 power in the numerator and a 3 in the denominator. So the very last thing you would do is write this as log of y to the 4th over x to the, and you would take 3 minus 1/2, or that's like saying 6/2 minus 1/2. And so I would have x to the 5/2 in the denominator. For B, let's take a look at B. For B, I'm going to kind of do the same thing, but anything with a positive, so these two right here, they're going to end up in the numerator. Anything with a negative is going to be written in the denominator. So let's rewrite this as natural log of x minus the natural log, and I'm going to write this as x minus 5 all to the third. Take that 3 up there as a power. On the next one, take the 5 up as a power, so natural log of x plus 5 to the 5th. And so I have a natural log of x is positive. The natural log of x plus 5 is a positive in front of it. So I'm going to write this as the natural log of, those two end up being product in the numerator. And then the negative goes into the denominator. And that's all you can do with that. Okay, let's look at these guys. And this this line is not really here. That's my cursor on the PDF. They want to solve each one. Let's take a look at these two. The first one is one of the easier variety because I can write 81 as 3 to the 4th. And if I do, then it's easy to see then 3 raised to the x is equal to 3 raised to the 4th. Therefore, x has to be equal to 4, and you're done. The more difficult ones are when you have 5 and 25 perhaps, but I can still write 25 as 5 squared. So if I do, this leaves me with 5 to the 2x minus 1. 25 is 5 squared, but that 5 squared is still raised to the 2 minus x. But when I have a number raised to a power and that's raised to another power, that's the same thing as the a being raised to the product of those two powers. So I'm going to take this 2 and multiply it by 2 minus x, and I'll do that by distribution. So I end up with 5 to the 2x minus 1 is equal to 5 to the 2 times 2 becomes 4. 2 times minus x becomes minus 2x. And now I have the same situation where I have the same base, 5 raised to 1 power is equal to 5 raised to another power. So those powers must be the same. And then I can solve it and then just have a nice linear equation here. So I'll add 2x to both sides. I'll add 1 to both sides. And this gives me 4x equals 5. And then, of course, if I divide each side by 4, this gives me x equals 5/4. Let's look at 44. 44 says solve the log equation. So let's take a look at, let's say, C here. C is log base 4 of x plus 3 plus log base 4 of x minus 3 equals 2. So I'm going to use the fact that I can rewrite the sum of two logs as the single log of the product. So this on the left-hand side becomes the log, still base 4, of the product of x plus 3 times x minus 3. And that's still equal to 2. Now that I have a single log on the left-hand side, I can rewrite this as an exponential equation. So that is 4 gets raised to the 2, and that's equal to this expression inside, x plus 3 times x minus 3. Now it's going to be a quadratic, but I need to set quadratics equal to 0, so I'm going to expand this right-hand side. Say x times x is x squared minus 3x plus 3x, and then minus 9. On the left hand equals 16. But the minus 3x and plus 3x cancel out, and this leaves me with 16 equals x squared minus 9. And so here I'm going to subtract 16 from both sides. And there's a couple of ways that you could do this, but here we go with this one is x squared minus 25. And then, of course, x squared minus 25 can factor to x plus 5 and x minus 5. And so then I set each of these individually. X plus 5 equals 0. Or x minus 5 equals 0. And if I subtract 5s, I get x equals negative 5. Or if I add 5s, I get x equals 5. And we've covered quite a few of the next ones in both review sessions. In fact, all 3 review sessions we've covered these in. So I'm going to look at 51 next. '51 says evaluate. And we've got the sigma notation, and they say I equals 0 to 6 of 2 to the I. So that means that I'm going to replace I with 0 and then add the next term where I've replaced I with 1 and add the next term where I've replaced I with 2 all the way up to 6. So that's 2 to the 0 plus 2 to the 1 plus 2 squared plus 2 to the 3rd plus 2 to the 4th plus 2 to the 5th plus 2 to the 6th. So 2 to the 0 is just 1. 2 to the 1 is 2. 2 squared is 4. 2 to the 3rd is 8. And 16 and 32 and 64. So we just add those up. Whatever that is, 1 plus 2 is 3, plus 4 more is 7, plus 8 is 15, plus 16 is 31, plus 32 is 63, and then plus 64 is 127. All right, this is not helpful. I'm going to check that. And I'm right. And I wish my whiteboard would stop shutting down on me. Okay. All right. So 52, let's look at 52 here. 52 says for each of the following, the nth term is given. Let me just steal it. For each of the following, the nth term of the sequence is given. Find the first 4 terms. So on any of these, B is just as good as any. I really am just replacing n with 1, 2, 3, and then 4. So A1 is my first term. N is 1, so in n squared, that becomes 1 squared minus 1. but that's 1 minus 1, so that is 0. My first term is 0. My second term is 2 squared minus 1, but that is 4 minus 1, and I have 3. A sub 3, or my third term, is just 3 squared minus 1, but that's 9 minus 1, and 8. And then a sub 4 is 4 squared minus 1, but that's 16 minus 1, and 15. And that's all they asked for. What are the first 4 terms? There they are, 0, 3, 8, and 15. Know how to go the other way with sigma notation. If you're given, let's look at, this is number 53. Let's do the one we haven't done. I think we've done all of them at some point in a review, but let's look at E. E is 1 over 2 squared plus 2 over 3 squared plus 3 over 4 squared plus 4 over 5 squared and plus 5 over 6 squared. And so my sigma notation, it's easy. There's a couple of ways that you could do this. And I'll evaluate, of course, to see if yours is correct rather than just if you cookie cutter, you know, got the same one that I would have written. But if it were me, I would start this at 1, and I'll use J. Doesn't matter what I use, but I'm going to just use J. But I'm going to go to 1 to 5 because I've got 1, 2, 3, 4, 5. And so that tells me that I've got a J in the numerator because it'll just go from 1 to 2 to 3 to 4 to 5. But in the denominator, these denominators are always, before we square it, this number that is here is 1 more than my numerator. So in my second term, my denominator is 3 squared. In my third term, my denominator is 4 squared. Well, that's just a J plus 1. And then that gets squared. So know how to take that sum and write it in sigma notation. Let's take a look at B as well. Because B is 2 minus 4 plus 8 minus 16 plus 32 minus, and then just dot, dot, dot. And that dot, dot, dot means this thing goes on forever. So when I do my sigma notation here, whatever happens, you know, I don't know where I start. I'll use I. I'm going to start somewhere, but I'm going to go to infinity. It's never going to stop. But it should be easy to see that this alternates, goes from positive to negative, positive to negative. So I'm going to use -1 to the n. But if I start at 1, now, sorry, I've chosen I to be my index, so it's going to be -1 to the I. But if I start at I equals 1, -1 to the 1 is negative, and my first term is not negative, right? So I'm going to just make the choice to go start at 1, but I'm going to increase my exponent by 1 so that my first term is -1 to the I plus 1 power, which is 1 plus 1, so that's 2, and that goes positive. And then I just have to figure out the rest of this. How do I get 2, 4, 8, 16, 32? Those are just powers of 2. And so I can write it as that. And again, there's a lot of ways that you can write this one. This is a way to do it. But this is how I would do it off the cuff. And let's look at the very last problem on that review is 55. All right, and they give us this. Find the first 4 terms of the recursively defined sequence. So let's do A on the left. Can I steal part of this and move it? Nope. All right. We'll do A on the left. So they give us 2, right? We have to find the first 4. 2 of them are given to us. So I already know a sub 1 is negative 10. And I know a sub 2 is 8. And then it tells me this, a sub n plus 1 is equal to a sub n minus a sub n minus 1. But I want to find my third term, so I've got a sub 3. If I'm looking at this, though, this is defined by a sub n plus 1. So that means 3 is my index of n plus 1. But if I subtract 1 from both sides, then I get 2 on the left, and I just get n on the right. And if I subtract 1 more, then I get 1 on the left and n minus 1 on the right. And so a sub 3 is, n is 2 now, so this is a sub 2. But n minus 1 is 1, so this is a sub 1. So that is to say that a sub 3 is the second term, a sub 2, minus the first term, a sub 1. So that is 8 minus negative 10. And that's the same thing as 8 plus 10, so I get 18. The next one I want to find is a sub 4. But again, my definition is a sub n plus 1, so that tells me that n plus 1 is equal to 4, or n is equal to 3, and n minus 1 is equal to 2. So a sub 4 then is a sub n, and n is now 3, so that's a sub 3, minus a sub n minus 1, but n minus 1 is 2, so that's minus a sub 2. So this equals my third term, which was 18, minus my second term, which was 8. And so my fourth term is 10. And finally, let's take a look at B in 54. B tells us that a sub 1 is 256. And then a sub n plus 1 is equal to the square root of a sub n. So I need to find my second term. But if n plus 1 is 2, n is just 1, so this is the square root of a sub 1. But I know the square root, I know a sub 1 is 256. And so it's just the square root of 256. And that is 16. So that tells me a sub 2, my second term is 16. But a sub 3 would be then the square root of the one previous, so a sub 2. But again, that's the square root of the guy that I just got is 16. And so this is 4. And then, of course, my last one would be a sub 4. And a sub 4 is going to be, they're all going to be just the square root of the previous one. So that's the square root of 4. That's 2. And I'm done. I've found all 4. But thanks for watching this. Again, shoot me any questions that you might have, and take care.